if you have a good duster.
It's supposed to be rubbed with a wet sponge, but the chalk goes on one nicely. I'm told the chalk is no longer scratchy as it does here. But my donation still holds. I'll donate one which goes up and down when I retire. Now I can't. So it doesn't matter whether they put a new one or not. So assignment, online assignment. I had thought that I don't put it, but I think I'm going to make it, you have been nice to me, isn't it? So I'm going to make it active and make sure that I take the best mark. So you can start attempting the 100 numbers, you start, you fail, you start, you do it until when, so the system will give me the best mark of your attempts. I thought that would help you to look through and probably read a little bit. Does that make sense?
Yes.
Because I was like, now if I take the first attempt and some people are just going to wait until when they just go there for a chance, then it loses meaning. So I'm going to use it as a way of you going there to sort of revise. Like you do this one you didn't know, you go revise, then you go back, probably this time get it, and then eventually be able to get something. So we left when we had started the and we had assumed that RC is so much greater than RE, and then which would mean that RE would also be approximately RBE and beta, which who was asking about beta, what beta is? Are you talking about beta or someone else? This what? Let me call your friend this. This what? So who is that?
Eric.
Eric. Eric. Now do you know about the beta? Anyway, we left when you almost knew, but just wanted to know whether you got it perfectly. So we're going to look at the numeric example with some figures whereby, and in Mericon, you can find out Mericon and see what values, do this. For example, if we got beta being 100, we had beta equal to 100, have RB equaling to 1 kilo ohms, have the RCE being about 50 kilo ohms, and then RE about 1 kilo ohms, which fits with the assumption that RCE is much greater than RE. With RE being about 1K and RCE being about 50 kilo ohms, you can see that bit. And then RE being almost like RE, we are having RBE as 1K and RE being 1K, and of course with beta being above 1, which is this example. So this would imply that our amplification, our voltage amplification would be the same as beta RE over RBE plus beta RE. Beta is 100 times RE 1 kilo over the RBE 1 kilo plus beta, which is 100 times the RE, which is 1 kilo. This is the constant, so these are kilo ohms go away, and we are looking for amplification. Amplification is the ratio of voltages, so it is dimensionless, it has no units. So that's why I'm not bothering myself putting the ohms. And this will be the same as 100,000 over the so the other k goes, this k, if we factorize away k, we go with that k, so we have the 100 over 100 and 1. This is equal to 100, sorry, I say 100, so I use some other language, so I'm sorry, plus 100, so this is the same as 100 over 101, what do you get? 999.999. The input resistance, remember, it is about for amplifier, we need to know the voltage amplification, we need to know the input resistance, we need to know the output resistance. So for this example, with these values, the input resistance Rin would be the same as RBE plus beta Re, which would be the same as RBE is 1K plus 100 times the Re, which is 1K. And then we would have this being the same as 101K. 101K. And this is resistance, which is ohms. R out is equal to RBE over beta, which would be the same as RBE is 1000 ohms over the beta, which is 100. So this would be the same as 10 ohms. I cancelled the case because they are thousands, but here is this was kilo ohms. This one is dimensionless. Then we get on. I have found students having issues with coming up with the units, even when you did a bunch of dimensions in I don't know which class, but in medical. And you could use R out. Remember the formula we had? R out being the same as 1 over beta plus 1 over the RBE plus 1 over RE plus 1 over RCE. This is small. And this would be the same as 1 over 101 over the 1 plus 1 over 1 plus 1 over 50, sorry. And this would be the same as 50K over the 5101 hopefully you are looking at everything humbly. It's not a problem. Once you go back to the, I almost said to the dormitory, once you go back to your hostel, residual home or hall of residence, just grab the paper and go through again, just to follow the formula. With this kind of small example we have, or simple example we have looked at, we note that input resistance was equal to 101 kilo ohms. So that means it is very, very large. And then the output resistance, which you have just put in there in an alternative bit, when we got 10, it means that it is very small. You can imagine the resistance of 10 or a mere 10 ohms. So now I think our vision is bright now that for an amplifier, it's good when its input resistance is low. Remember, because you don't want to waste your, very large. And this means that you don't want to use anything within the resistance. It should be able to repel everything to be used in the output part, like the way we look at the voltmeter. The voltmeter, the multiplier kind of does not consume any current, so that you can be able to measure it in terms of the PD and depict it as the voltage that you are trying to measure. Whereas for the ammeter, you need a shunt of small resistance so that you can determine the current which is passing there and be the current you are measuring. So I want you to be now, this should stick in your mind, that for an amplifier, its nano resistance is humongous and its output resistance is very small. The voltage gain in this case is unity. Unity, people keep saying unity, which means being one. And in this case, that's why we call it, hence the name emitter follower. That's why we call this common collector amplifier. That's why we call it the emitter follower. The circuit is used to match impedances, e.g. drive low impedance loads such as a loudspeaker. Remember, we are talking about amplifiers, and the simplest of an amplifier I can talk about is a subwoofer. So the circuit is used to match impedances, e.g., or for example, to drive low impedance, loads. T laws such as loudspeaker. Since they are laws, so they are loud speakers. Is there a quiet speaker? I don't know who chose to call it loudspeaker. Is there a quiet speaker? Loudspeaker. Sometimes we make, once you change the volume, which volume of, the volume of the radio is the potentiometer which you are using in the lab. That potentiometer in the lab is what we call, is the same as the volume of the radio. So when you are increasing the volume, you are actually reducing the current. So when you, reducing the resistance. So when you are at full blast, there is no resistance. You are using all the current. That's why if you are using batteries like for us who grew up in the village, in a few days your radio is just coughing. Doesn't say anything. So you have to keep the volume for somewhere. You hear things you don't hear, but at least you spend like 2 weeks. I had a family with some guys, another paper is there. And so for them they had the radio cassette. So for them when it can no longer run the tape, then it is useless. The batteries are useless. Not for me. It was supposed to be radio cassette, but I think the cassette was malfunctional. So I would sometimes have a box, I had a wooden box where I can put like 10 batteries and still blast the music. So their trash was my treasure. So, but look, when we say low impedances, such as that of the loudspeaker, we are speaking to this output characteristic of an amplifier, but the output resistance is very low. We also note that the current amplification, which is now equal to officially, this would be IE over IB equaling to beta, would be called the current. We go to the last one to crown up the amplifiers, which is the common base, or I should say that you do it as the assignment or exercise. This is one thing I love about teaching mature people. If I'm tired, I just say assignment, and then you do. But those kids will tell, we pay fees. If those of you are going to be teachers, you can't do that. They say, we pay fees for you to teach us. Not again to suffer. Like how I normally make a joke that I don't attend concerts, but if I attend a concert, I cannot sing along with the artist. How? Singing. I pay money, then I sing with you. Sing your things, make me after I go home. But I don't go to those things, so we go to the common base amplifier. So yesterday was an experience for me in terms of how you are doing in practicals and your knowledge about electronics and probably how the country will move forward. So, for those of you who are coming on Friday, I'll be alone. I'll be solo. Okay, the technician will not be there. So probably the other colleagues also will come back. But when the technician is not there, I say I'm alone. Because there is apparatus which is faulty, naturally. and I can't know that it is faulty. So me, I will be following how it should work. And I think the ICWs know what I'm talking about. They had worked with the faulty generator until when the technician came and said, this button is faulty, so you have to make sure you hold it nicely to make sure that you get the VPP. And once you have gotten it, don't touch it again. You get the point? So, and then those who were doing E1, you realized, of course, we're not going to do the same thing, but you realize that, Steve-O, now you are on E1, you realize that, you know now the reason why I said don't switch on before I come. Because it is hard for you to realize that the circuit you have connected wrongly. It is only me who comes and sees that the wires are in the wrong places. And if you are connected wrongly and you flip the switch, you get some nice, it's not even a nice smell, you get some good smoke. You get smoked. And it is not pleasant. So for those of you who are on Friday, let's give me peace, okay? Because I have to first take through the ones who are doing D1, especially because there is no one who will be doing D1 who has done NAD. And if the both D1 and D2 have not done, it means I have to be having that group. I have to first teach them what to do, then I make sure I verify all circuits. So make my Friday nice, okay? In that regard. I just wanted to tell you in advance. He may probably, I told him even when he was telling me that he may not do it, I said, I'm going to make sure that you. I've done solo, like last semester I did 2 weeks solo. I was always alone in the electronics and instrumentation in the same lab. So it's not a problem to me, but I don't want to get headache. I tell you, don't switch on, I go down to pick something, I come, things are smoking. I will not be happy, but I'll fix if most of the things are fixable. The things which burn up are transistors and capacitors. Is that? But the faces I see are like almost all our Wednesdays, except the other ladies, because in Wednesday we have almost like 1 or 2 ladies. But all the other ladies I know are for Friday. But the guys I see here, it's like they were there yesterday. Oh, it's because I meet the same fellas in the lab. Zake, you dodged. I know you are thinking hard that, but he didn't see me yesterday. I know you were not there yesterday, but you dodged. Someone told me it's solo because you are not there, isn't it? You are supposed to be doing E2. I have a bad memory. I remember everything. I call it bad because it wastes my time, remembering things which are a nuisance. It is fair to look for something better. So we got the variable capacitor has, if you go like in a radio, it's some are round, but most of them are like squarish. And then, I don't remember whether up here it is squarish, but then cylindrical down here. But all I remember, there is a slot for a minor screwdriver where you can adjust the volume. I used to bring my radio to explain the RCL when I would be teaching the AC circuits, RCL, so that I had to just maybe I could do it again just for you to know the variable capacitor. And then I will draw this part. Then we have the potential divider. What was the purpose of the potential divider? Let me see who can answer this. Joel, what is the purpose of what process? What is the process, or what were we doing when we had to use this potential divider? Okay, I can give you hint. Stability and biasing. Which of the two? B. Now I did not say A is this one. Let me just do my stuff because I want to finish this part of the transistors today so that we do other stuff. We start on, not interesting, but we start on 3 things because most of you test when you are doing these things. I try to make sure that these things don't look exotic, much as they are deemed exotic to some people. And it's other people who think that science is exotic, but we were scientists ourselves. I was telling one of the students, project students, that the ancestors, those of you who come, who are from the central region, I don't know this month in my language, and I don't know whether Gava knows this month in his language, the month in the year. For example, January is Gatonya, or Baganda, the bananas. I'm trying to say this so that you see how fake we are in our rich knowledge. It meant that Matoke has been so, has put on fruits and whatever, even has become yellows, and they are just falling off. And that's why we call it the Gatonya. So that's why they call it Gadonya. In February is Muturansanja. It breaks the, is it the one with the fibers or the leaves? The leaves. So if you went to the garden just to make sure you look after your garden, you don't hustle. You can even fool like this. Then March is for buying seeds. Then April is when these things fly off. Fly out, the swamp. So then, I don't know about May. What May means is the musico. Then the June is Sebaseka. Probably the fields are looking good, so the man is happy. And then July is Kasambula. You are trying to clear the garden, cutting whatever, and making sure that where you harvested, you are now preparing it for the next time. And then whatever you harvested in September is Mutunda. You can sell some. Have I jumped? I have August. I don't know why they called it that. Maybe when they have taken the Mwemba, they become so drunk and become starting protesting around. Then Mutunda, then Mutungo, then the Senene comes, and then we have Mtemfu. I don't know what Mtemfu means. And then the year ends. So the old people experienced the seasons and did what is supposed to be done in that season. A person who was busy now trying to prepare the garden during this February, March, cannot complain about the sun. For what? They are buying seeds, they are preparing the garden, it is very dry, easy to till. Then for us who are in office, we are crying over the sun.
But there is a climate change.
There is nothing like climate change, it is a hoax to eat money.
Yes.
I'm telling you, if you were busy preparing the garden, you don't care about the sun.
Yes.
In June, if you are having your harvest and you want your sorghum, your beans, your maize to dry, you don't complain about the sun.
But in May, when your maize is flowering, And the sun
Let
comes.
me now let me now go. But you see how people whom we think they were not educated made their ear okay. They made sure that they have labeled their ear in the events that should take place. And indeed, in the morning, if you were to be traveling in this rain, the Nswa were flying everywhere. Even if you didn't travel, if you have a house with the lights, they were there. Because this is their season. But because of modernity, we think that we should eat maize from January to December. That's what happens. Anyone who wants maize just goes to the market. It's maize. You don't even know where it comes from. And fresh vegetables are there. So we don't know. We say, but we are no longer seeing the vegetables. Yeah, you know, climate change. Which climate change? Okay, let me conclude this point so that you understand what I'm saying. You will say there is climate change, okay? I agree. Then we should adopt renewable energy. True. Then you adopt solar. True. Forests grow. True. It rains every day. True. What will you use with your solar?
Problem solved.
Problem solved. How? You got solar to use the sun and conserve the forest. You have conserved the forest, you have gotten rain every day. Your panels can no longer get the sun. So are they useful?
Then you cut the wood.
And that is how it is. God is not stupid. God put things for us to survive, you know. Do things when, if it is a sunny day, go to the beach, open up and relax. When it is raining, now do what rain do. Now all roads were almost at the standstill, all road constructions, during this dry season. Now it is becoming wet. They are going to start being busy. They think it is washed away. They put it, I think Africans. I'm sorry, let me go by this. I never crammed what they taught me. I did what I could understand. And I still pray to God that I should understand the little I can understand, not just cramming. Someone tells me this is like this, and say, I go with my head swinging, this is like this, how? So we have a capacitor here, C2, and then a capacitor here, C1. Then our common. So the common, this common here is like the ground. When we say common emitter, it's ground emitter, ground base. That's why now we have made this base here, and through this other capacitor or whatever you see it in form of this other resistor, we have made sure that it is connected to the common. So on the multimeter, when you that hole you see, because the reason I'm now talking about this, when one or two, three groups, when I say, and remember when I tell you do this, don't think that I'm trying to be not helping you. I want you to do things on your own. So when I say you turn it and put it at DC, I want to see whether if you, because there are students who do practicals after. You say, oh, they are now doing projects, and they are like, as if they have never seen the thing. Because they would ask the technician, this one has refused, comes and says, okay, this, okay, the value is here. Don't feel happy that your problem has been solved. You are going to go when you are down. You don't know how it came. If an oscilloscope is there, My job is just to teach you how an oscilloscope works. You are the one to use it to get what you want. And remember, I am the UNEB and I am the examiner. So don't try so much to focus on giving me results, thinking that that's when you will pass, and then you forget that you need your skills. I know it is an exam, every paper is an exam, but don't try so hard to present to me good results, but when you understood nothing. R1, R2, RE, RC, VCC. Please, this VCC, the 15 volts, always measured with the multimeter. Remove the 2 wires down here, or the power supply, then plug in your multimeter and just be sure that is the value. Because I don't want to smell anything Friday. Whether I walk out or not, I don't want to smell anything. Because those things don't smell good. But I think also they are the ones which killed my eyes. I used to solder stuff, so I think that's more from the soldering, whatever. Not from here, from home. I think it is the one which spoiled my eyes. But I'm not young either, so I have overused my lenses, my eye lens. So this is, and then here we have the ear. Pardon? The TV. No, the TV and radio, I watch them with a relaxed mind. I don't stress. Sometimes I even, when I grew up, I started in second senior 126 as a day scholar. We didn't have TV. I watched color TV when I came to campus. Color. I had watched some black and white, not even TV, but movie from some, yeah, maybe. I watched the color screen on. I remember watching my first movie. Some village boy took me to the movies, the video hall. I came out like this. I was feeling very strong. I think I had watched Van Damme fighting with this other Bande guy. So I was like, it's like I could kick somebody. So the C3, yeah, this value one, C3. C3 is a large capacitor. And it bypasses R2. I thought bypassing is, okay, you now understand it. We use northern bypass, but you find people driving there as if they are on a tour guide. It is a bypass, you are bypassing jam, so rush. Go wherever you are going. So we can use the idea of small signal parameters. So through the small signal equivalent circuit, it can be shown that I'm not going to draw the circuit, so I'm sorry. It can be shown that AV is equal to beta in the parallel of RC and RCE divided by RBE. The input resistance, and the second thing about amplifiers would be approximately RB over beta, and this will really be very small, we say, and not to be said, interestingly, and then R out would be approximately equal to the R out of the circuit. This is compared to the common emitter arm. Compared to the common emitter arm. If we were to use the things in the so we can have an alternative circuit, and I will I have no choice but to chop to wrap up everything.
That's different at the bottom.
Yeah, R out is equal to R out, is approximately equal to R out. I know it is confusing. We had an R out which was calculated, and then we had an R out of the equivalent circuit. So if you looked at the R out of the equivalent circuit,
meaning the last example.
yes. The other way, if you compare with, for example, the simple example of the common emitter, then you will be able to get us. An alternative circuit of this amplifier, I'm slow to make sure that you don't get scared. So the alternative circuit of the common base arm we have V in going through C1, then we have the transistor can face anywhere. Those of you who will be doing P14, if the transistor is a curved thing here like this with a flat peak, and then with the 3 legs. This one is automatically a base. If you look at it with its legs up, okay, then the curve is like this. Then these 3 holes will be collector, emitter, and base. This is if the legs are facing you. If you now put the legs in the breadboard, that means the emitter goes down if it is facing this way. So for D14, you have the transistors drawn like this. So if this flat part here is this line here which we normally draw. So if the other transistor is like this, that means that when you now plug it facing this way, then base remains here, but now this one becomes collector and this one becomes emitter. So when you are connecting on the legs, you must know that one of the transistors, probably one on the left, if I'm looking for the collector, I mean for the emitter, I'm looking for it up there. And then the collector will be
Excuse me, even before you do the alternative circuit, the circuits that we have for which you are making the alternative, maybe clarify a little bit, because the input seems to be on the emitter.
Yes.
Okay?
Yes.
And is that a reverse bias now, or is the voltage on the base now higher than what is on the emitter?
It's a common base, so our base was connected to the common. So we can no longer have IB as the input because we put it to the common. So now we are grounded more or less. So we cannot do what you are doing in E3, adjusting your IB, okay, setting your IB to a certain value, then look for IC and VCE to get your characteristics. Now we have to make the transistor act as an amplifier by now adjusting an input at the emitter.
But if we go, maybe I didn't understand the basics.
Yes.
I assume that if we take the diode kind of whatever,
Equivalent.
then
So
you can't have anything moving out.
yes, there is a diagram, nice diagram with everything in the notes on Mwele, which I think I didn't explain. Hopefully, I hope I will. You have these two circuits here. You have a power supply here, and then you have another power supply here, and then you have flow. So if assuming we have a P, NP, I don't remember which one is which. This was, this is now a diode, and this is a diode. And then this is our base now. This could be the emitter, this could be the collector. So I think what you didn't get is how the biasing of each of these junctions eventually amounts to the way a transistor works. Now, for a transistor, we are supplying it with VCC. This well, I haven't, this, that. So with VCC, we put VCC. It flows towards the junction, which is always reverse biased at this point. And then we have IB, which will help us refuse some of the current from the VCC to come down here. When we put the biasing, is when we now put this other potential divider to divide some of the current from VCC and contribute to the IB. So that when we change the value of the IB, it also helps us on how much we had added and be able to see what could be gotten at this other point of the output. Now, it depends on what we're using the transistor for. We could be using it as a switch, like those who will be using it in D1. D1 or I think D1, because D2 is essentially proving the Boolean algebra. So in D1, you'll be able to use now a transistor logic with a couple of diodes or two transistors to form a gate, a logic gate, so that you can allow this to go through or disallow it to go through. You can say, if I put in a 5, it produces for me here a 0, a ground. So it depends on what you are using it for. If, let's say now, the way we are using it as an amplifier, we want to make sure that we get an output that is significant. So we have grounded the base. Now we still have the current from the upstairs from the VCC. Now we want to play with that current. How much can flow from VCC? You see, it comes from VCC, goes through RC, and would wish to now go to the junction within the transistor. But also there is this other part where we are drawing the output. So part of it goes to the output, part of it goes to the transistor. So it's up to the transistor. If the transistor is saying, please don't pass here, all of it goes to the output. If the transistor here, if the biasing, if the input we are putting now down here at the emitter, if it is resisting too much, a lot will go to the output. If it is resisting less, less will go to the output. And that less or much is what determines whether it is amplifying, whether it is reducing.
Now, my issue is about the direction of the junction itself. Here, I was assuming the base is P.
The idea, the biggest idea is that this is the guy who tells you where the positive charges are flowing, and which will be the direction of the current. Now, when the direction of the holes is in this, like for now, it is supposed to be flowing, they are supposed to be flowing this way. Now, when this current is, this is a negative here, that means that they have also a possibility of flowing this other side because of being attracted from this side. If you put the positive here, you make them flow to go across the junction because they are being repelled by these other positives. When you put here negative, then they are attracted. So you are making the junction to be even, the depletion region even to be more bigger. So now it is like resisting everything and making you now have the current, have another place to go. So that's the, I want you to see it as like we are playing here, as we are playing, some people are being called to go and pick some sweets. Then you reduce the people who are here. Then does that help us to have a good community here, or is it now making us lose our unity? I don't know whether you get the point.
So in this case, we have the positive connected to the N. Okay? So it's like from the emitter side, then nothing is going to go out of
I just want to see what, okay, so when you get the V in at C through C1 on the circuit which I do, the one and so it reaches at RE, so you have some part which came from the biasing of these two, okay, the divider, and then you have the VCC from the other side of supply. The VCC is also bringing a current down. It may not go through to come here, but it also depends on how much this could be repelled. If it is 5 that is stuck here, and then you have 10 coming from down, 10 can now comfortably go because it's nothing much, the opposing bit is not too much the other side, so you don't have much coming from this other side. I don't know how to make it come out easily. I will get one of the 1 hours to make sure that we understand the biasing of a transistor. Okay? Is it okay? Yes. Because I put that diagram thinking that it would help, but it is not helping. So I have an alternative circuit which I want you to draw, and then we'll say bye-bye for the day. You have a test again today? No. You have a lecture. So let me be quick, and then I let you have the lecture. So we can have V out here, and then have the base here. This is where is the winner? Tell him that when he dodges, I get to know, because he chose to be monogamous. And please, if you can access the YouTube videos, not mine, you can get from MIT, and those guys will explain better than I can, because for them they use these transistors beyond teaching and questioning about the applications in exercise and examples, but to application industrial scale. And mine is mostly about this bit of the classwork and our lab. You know how our lab looks like? Our lab. So for them, these are guys who interact with Silicon Valley. So they go down there and explain how things are done. But that doesn't mean that you can't be like Elon Musk, who refused to do his further studies, and instead he has SpaceX, which is producing Tesla vehicles and all the rockets. The Falcon rocket comes back by itself after sending out. It's not that he was an MIT and Zuckerberg, you know, who sells your photos, is a dropout of Harvard. Don't drop out of school. Don't drop out of school to be like Zuckerberg. The lack of the chicken is not the lack of the what? So don't do that. So I see you tomorrow for the Friday group. And then on Tuesday we shall start on the feedback.